topic of our discussion is from chapter number 1, periodic classification of element and periodicity, position of hydrogen. Recently we have discussed about the position of hydrogen. I told you that the position of hydrogen is also has a dimensionally periodic table, and the position of hydrogen can't be verified and can't be placed in modern periodic table properly. Let's see what is the position of hydrogen, because hydrogen is sampled with group number 1A, group number 4A carbon and silicon family, and group number 7A halogen family. Hydrogen resembles with these three group members, which have hydrogen shows some properties of group number 1A, also shows some dissimilarities or similarities with the group number 1A. Let's first of all we consider what is the similarities of hydrogen with group number 1A element. So, student, what is similarities? Number one, hydrogen has one electron in one s. Hydrogen, dear students, has only one electron in one s shell. Like other alkali metals, all alkali metals has electronic configuration ns1. Ns means, dear student, here any shell number 1, 2, 3, 4, any shell number, but there should be s1 electron in valence shell. There should be s1 electron in valence shell. Lithium has 2s1 electron. Sodium has 3s1 electron. Potassium has 4s1 electron. It means that all alkali metals and hydrogen has same electronic configuration. They have one s1 electron in valence shell. This is the one similarities of hydrogen with alkali metals. Second one is tendency to combine with electronegative elements such as halogen. Hydrogen and halogen also combine with alkali metal or halogen to form ionic compound, like for example hydrogen also combine alkali metals, for example sodium iodide, sodium hydride. Sodium combine when hydrogen, it form ionic compound. Clear? uh, these ionic compound when dissociate in water, it gives ions. Dear student, when hydrogen ionic compound of hydrogen combine with alkali metals and also form ionic compound, when these ionic compound mix in water, it dissociate into its ion. This is also the similarities between the hydrogen and alkali metal. Third one, sorry, and what is the difference between the group number 1A and group alkali metals and hydrogen? First of all, hydrogen is non-metal. As we earlier discussed, that hydrogen is a purely non-metal, but all other alkali metals group number 1A elements are metallic in nature. So this is the first difference between the hydrogen and alkali metal. Second one is the does not lose electron easily. Hydrogen easily lose, alkali metal easily lose electron to form a positive ion. Like let's see this, when sodium loses one electron, it's form Na positive, and same here when lithium loses its one electron and form Li plus 1. So hydrogen can't lose easy electron. Hydrogen can also lose electron and form H positive ion, but not easily, because due to high electronegativity, non-metallic nature. Number 12, hydrogen exists in open atmosphere. Like students, sodium, lithium, alkali matter does not exist in atmosphere. The alkali matter is placed in inert solvent, for example petroleum, ether. They react rapidly with water and air. So alkali matter does not exist in open atmosphere, but hydrogen exists in open atmosphere. This is the about the similarities and difference between the group number 1A elements, alkali metals and hydrogen. Let's we see the second one, Group number 4A, first of all, we discuss about the similarities of hydrogen with group number 4A element. The first similarity is that they have filled valence shell. Carbon, let's see the first member of group number 4A, carbon. Carbon has 6 electrons. Let's see the electronic configuration of carbon. The electronic configuration of carbon is 1s1, 2s2, and 2p2. As you see that these two subshell S and P belongs to the shell number 2, 2s2 and 2p2. This is the valence shell of carbon. This is the valence shell of carbon, and you can see that there is only 4 electron in carbon valence shell. 2 plus 2, there is only 4 electron. As you know that according to octet rule there should be 8 electron in a valence shell. So there is only 4 electron in the valence shell of carbon. So we can say that this is half fill. Carbon have half fill valence shell electronic configuration. As you students see that there is only 4 electrons, so we can say that carbon has half fill valence shell electron, and likewise carbon hydrogen has electronic configuration 1s1. As you know that S contain only 2 electron, so because hydrogen has 1 electron in its valence shell, so it's contain half fill valence shell. So we can say that carbon and carbon family and hydrogen only contain half fill valence shell electronic configuration. So that is the first one similarities between carbon family and hydrogen. Second one similarity is that combining with other element through covalent bond, hydrogen and carbon can form covalent bond with other element. Is that clear? Number third, also possessing reducing properties. Carbon and hydrogen also possess reducing properties. Let's see the example of reducing properties. When hydrogen combine with copper oxide, they form metallic couple and water. In this case, copper oxide is reduced into copper metal. So hydrogen possessing reducing properties, likewise carbon also possessing the reducing properties. When tin oxide react with carbon, is formed tin metallic tin and carbon dioxide. So carbon and hydrogen have reducing properties. This is the third similarities between the group number 4A and 4A, or we can say that carbon family. Now we see the differences between the carbon and other element of the group number 4A. So first of all, the differences is that carbon can form long chain. As you know that there is main properties of organic compound. We can say that carbon is the backbone of organic compound. They form long chain by combining with its other element. So carbon combine with the other element to form long chain by catenation, and but hydrogen cannot form a long chain. Likewise carbon, the silicon is also form long chain with the other element due to the presence of 4 valence shell in its 4 electron in its valence shell. The second one is difference is that carbon can form multiple bond. As you students see that carbon combined to other element by single covalent bond with its element. Other element carbon can also join by other carbon atom by triple covalent bond. So carbon can form double, single or triple covalent bond, but in case of hydrogen, hydrogen only form one covalent bond. Why hydrogen form only one covalent bond? Because there is only one shell, one electron is available in valence shell. That is why hydrogen form only one covalent bond with the adjacent hydrogen atom. So there is two difference between group number 4A elements and hydrogen. Carbon long chain can form long chain that exists the form of long chain. Likewise silicon also form long chain, but hydrogen form only one covalent bond, or multiple can form multiple bond due to the presence of one electron. Now we see the similarities and difference between the group number 7A, or we can say that halogen. So first of all we discuss the similarities. What is the similarities between the group number 7A? Let's see the First properties, hydrogen is a gas like halogen. Hydrogen, dear student, is a gas. It exists in the form of diatoms. Likewise, they can S2, F2, Cl2. All these gases, fluorine, halogen, bromine, or are over the halogen exist in the form of diatomic gases, but hydrogen is also existing as two forms. So we can say that this is the first similarities between the group number 7a element and hydrogen. Second one is that needs only one electron to complete valence shell. Hydrogen and halogen needs only one electron to complete its outermost shell. As you see that student, all halogen has electronic configuration np5, so they need only a one electron to complete its valence shell, and hydrogen also need one electron to complete its valence shell. So this is the second one similarities between the halogen and hydrogen. Third one is like halogen. Halogen can form F negative, Cl negative. Hydrogen can also form H negative. This is called hydride ion. It means that hydrogen can exist in the form of S negative, and halogen also exists in the form of F and Cl negative. This is the third similarities between the halogen and hydrogen. Now we can see the differences between the halogen and hydrogen. The first one is that forms S positive. Hydrogen can form S positive ion. They can lose electron easily as compared to halogen. Halogen, to compare with halogen, they form H positive, but halogen can't form F negative, Cl negative. They can't lose electron. Halogen only gains electron and form F negative, Cl negative, Br negative. But hydrogen can also form H positive by losing electron. This property is not related to the halogen. Second one difference is that form stable oxide but halogen not. When hydrogen combine with oxygen, they form stable oxide. For example, S2O, water is a stable oxide. Likewise, hydrogen peroxide S2O2 is also a stable oxide. But the oxide of halogen is not stable. It means that hydrogen and halogen also contain dissimilarities between these two groups. This is the dissimilarities between the group number 7a and similarities group number 7a with hydrogen. So when we ever place hydrogen is placed at the top of the group number 1a due to the similar properties with group number 1a, because mostly properties match with the group number 1a are alkali metals, due to we know that hydrogen is also monovalent and alkali metals is also monovalent. They also contain one electron in valence shell, and alkali metals also contain one electron. That is why hydrogen is usually placed as the top of the element in group number 1a. That is over at the topic of position of hydrogen. If we have any confusion, you can ask. Okay, dear student, love, please.